Let's be real. When you're holding a multi-million-dollar vessel steady next to an offshore platform, close enough just doesn't cut it. Precision is everything. But what happens when the weather turns? When fog or heavy rain or dust rolls in and your traditional laser systems just go blind? Well, today we are diving into the all-weather solution for marine positioning, the RadaScan system.
You know, the beauty of the RadaScan system is its simplicity. It's really built around just 4 key pieces of kit. You've got the sensor, which is mounted on your vessel. That's the brains of the operation. It talks to the passive transponders that you place on your target. And then up on the bridge, the monitor and marine computer give the operator a perfect real-time picture of everything. So let's see how they all work together.
So here's what we've got on tap for today. First, we'll hit RadaScan's biggest advantage. Then we'll get into the nitty-gritty of the physical install for both the sensor and the transponders. After that, we'll cover the connections, pop up to the bridge to see the operator's view, and we'll wrap it all up with a checklist to make sure you're getting peak performance every single time.
So what is RadaScan's secret weapon? Well, while laser systems are basically blinded by bad visibility, RadaScan uses microwave radar. What does that mean? It means it's almost completely immune to the exact conditions that shut other systems down: heavy rain, thick fog, even sand and dust. Simply put, RadaScan sees right through it all, keeping you safe and on schedule, no matter what.
Okay, now a system this precise depends 100% on a correct installation. I mean, you can have the most advanced technology in the world, but if it's not set up right, you're just not going to get the performance you need. So when it comes to the physical install, trust me, location is absolutely everything.
When you're mounting the main sensor, these are the non-negotiables. First, it needs a totally clear, unobstructed view. Second, it has to be on a flat, super rigid surface that can support 120 kilos. We can't have any vibrations. Third, and this one is critical, it has to be on a different vertical level than your ship's X-band navigation radars. We'll circle back to why in a minute. Fourth, get the orientation right. The inspection hatch has to face the bow. And finally, you've got to be able to get to it for connections and service. Simple as that.
And this picture? This is a perfect setup. See how they've placed the sensor high above the wheelhouse? That gives it this amazing, commanding view over the whole working area. It's up high, it's clear of any obstructions, and it's positioned for the best possible 360-degree coverage. That's what you want to see.
Okay, so the sensor is in place, but what is it actually looking for? Well, that brings us to the other half of the puzzle, the transponders. These are the little passive reflectors you'll place on the rig, the platform, or whatever other vessel you're working with. And hey, just like the sensor, where you put these transponders makes a huge difference. The main goal is to avoid any interference from metal structures, so you always want to mount them on outside corners. There's also a sweet spot for the height, not more than 2 meters below or 5 meters above your sensor. And if you're using multiple transponders, you need at least 7 degrees of separation between them. Oh, and get this. These things are passive, and the battery lasts for a full 12 months of continuous use. Pretty incredible.
This slide says it all, doesn't it? I mean, look at the difference. On the left, you've got a textbook installation. It's on an outside corner with a perfectly clear view. On the right, that's just a recipe for disaster. The transponder is buried in pipes and beams, which is going to create all sorts of reflections and blind spots. It's not just about getting it on the platform, it's about getting it in the right spot.
All right, the hardware is all mounted. Let's get this thing wired up. We're moving on to the essential hookups for power and data, and one of the most important, and honestly most overlooked parts of the installation, shielding. Okay, so you've got this super advanced microwave sensor, ready to slice through fog and rain like they're not even there. What do you think is the single biggest threat to its signal? I'll give you a hint. It's probably not what you're thinking.
Believe it or not, the threat is coming from your own vessel. Your powerful X-band navigation radar can actually jam the RadaScan sensor completely. The defense strategy is pretty simple, though. The best way is vertical separation, put them on different levels, just like we talked about in the checklist. But if that's just not possible, you have to shield the RadaScan sensor with a metal screen to block the X-band's beam.
So once you've handled that potential interference, the rest of the connections are pretty straightforward. The system needs 3 main lines. You've got dedicated power for the sensor itself, a separate power line for the internal heater if you're in cold climates, and of course, the RS-422 data cable that pipes all that positioning data right into your vessel's dynamic positioning system.
All right, let's head down from the mast and onto the bridge. We've covered the hardware, the placement, the wiring. Now let's see what the DP operator actually sees and how they use this info to keep that vessel perfectly on station.
So this is the operator's main screen, and it is all about clarity. You can see your own vessel right there in the center, and the transponder targets are shown with their ID numbers. In this case, we've got 350 and 355. The whole display gives you this clean, graphical view of your position relative to those targets, along with all the key data, like range and bearing.
Now, for the operator, probably the most important bit of data on that screen is the signal-to-noise ratio, or SNR. This is basically a direct measurement of your signal strength. A high SNR means you've got a clean, solid, reliable lock on that target. On the console, you can see the raw number, but that simple green bar graph gives you an instant visual check that says, yep, your position quality is good to go.
Okay, we're in the home stretch now. We've installed the system, we know how to read the display. Now let's just pull it all together into a final checklist of operational habits that will make sure you get the most accurate, most reliable performance from your RadaScan system every single time.
Now, this diagram shows something that's really key to understand when you're out there operating. The system is incredibly flexible when you're up close. At 50 meters, the transponder has a massive 170-degree viewing angle. But as you get farther away, that cone of view gets narrower. So at 500 meters, you need to be within a tighter 90-degree angle to get that solid lock. It's super important for planning your approach.
And just how far away can you be? 1,000 meters, 1 kilometer. That is a huge operational advantage. It means you can find the transponders, lock the system, and get your whole DP system proven out and settled well outside the standard 500-meter safety zone around an installation.
And that brings us to our final takeaway, your pre-op checklist. Before you go live with the system, just run through these 5 things. 1. Visually confirm you've got a clear line of sight. 2. Double-check your X-band radar isn't causing any problems. 3. Pick the best placed transponders for the job. 4. Look at the console and confirm you have a really strong signal quality. And 5. Here's a pro tip. Always deselect the sensor in the DP console before you realign a multi-target group. It'll save you from a sudden position jump.
So we've seen how RadaScan delivers that rock-solid, pinpoint accuracy right when you need it most. It really makes you wonder, right? With positioning this reliable, no matter what the weather is doing, what new, even more complex offshore operations suddenly become possible? What's the next frontier that a technology like this is going to unlock?